Okay, test review number 16. Test review 16, number 9. Suppose that f of x equals a sine x plus b, given that f prime of 0 equals 3 and f of pi over 2 is equal to 5. Find a and b. Okay. We're given the original function. We're given information about a point on the derivative, and we're given information about a point on the original curve. So we can start wherever you want here. But we're going to have to look at the original curve using this point, and we're going to have to look at the derivative using that point. If we go ahead, do you guys have a preference? I mean, they both need done. I'm not really sure order matters until you get to the end and you see what all you have. Does that make sense? Because I think I would probably go derivative first. Maybe. I don't know. Doesn't matter. If I look at the derivative, keep in mind a and b are constants. They're just numbers, right? So derivative of a sine x plus b. What's the derivative of sine of x? Cosine of x. So the derivative of a sine x is going to be a cosine x. The derivative of b is just a number, right? So that's 0. So now you have a function, you have a derivative, you have information. If we go ahead and look at, they gave us f prime of 0 is equal to 3. So that's saying we're going to put 0 in place of x, right? So it's going to be a times cosine of 0. And what's that going to equal? It's going to equal 3. So you put 0 into the derivative, that equals 3. What is the cosine of 0? Cosine of 0 is 1. Okay, so this says that a times 1 is equal to 3. Or in other words, a equals 3. Okay, original function. F of x, so I'm going to say f of pi over 2 is equal to a times sine of x, so times sine of pi over 2 plus b. And that equation right there is going to equal 5. Excuse the cosine curve. Now, sine of pi over 2. What's the sine of pi over 2? Also 1, isn't it? So this is going to say a times 1 plus b equals 5. Or in other words, a plus b equals 5. I do feel backwards. I probably should have done this one first, but
that's what I did on my thing. I did normal F first, but it just seemed like the right way in my mind.
Yeah, I don't know. And my point is, does it matter? I mean, if you get this point, if you did the regular F first and you get this point, you're just going to stop here, aren't you? You're just going to stop here, and now you're going to go work with the derivative. In this case, we already worked with the derivative. We know a is 3, and so thus 3 plus b equals 5, and b is 2.
Okay, so that was a lot easier. I wasn't here when we did this, and I've been confused on this every single time.
Well, I was trying to remember, was it someone was voicing their concerns about their A's and B's?
I think it was me.
So I was trying to remember if it was you. I think maybe Jacob voiced a concern about A's and B's at one point. I don't know.
I don't know.
Someone was concerned that
I hate when other variables are like in the problem and I can't like solve for them like in a sense. So
Yeah.
like, it always throws me off.
How did you get through physics?
Ross, I barely got through physics. I dragged myself out of that.
Okay.
She's like,
What else do we want besides number 9?
I just
Part
have
of
a
my
question.
soul still lies
Does
here.
number 5, the change of variable one? Or the integration of change of variable one there yet?
I don't know if we're there yet, honestly.
Okay, alright, cool.
Number 5 is a good one to talk about. You need to recognize that as a specific integral.
Oh, that is the integral of sine. Or
Sine
covariance
inverse.
tangent, it could be.
Yeah, you need to recognize your trig inverse functions. And we are not to change a variable yet, or we shouldn't be. For some reason, I was thinking it was time to go briefly.
It better not be.
I know, I'm thinking, just got started. Did I really take that long on that A and B problem? Oof. As I said,
It's been started too.
there are days when that bell gets me. Either I'm thinking, and I guess this one I'm thinking, wow, it's only halfway through. Okay. So, number 5 is basically a recognition problem and then knowing how to use it. Back in lesson 64, we did our derivatives of inverse trig functions, right? And so back in 64, we learned that the derivative of sine inverse of x, or technically I shouldn't say sine inverse of x, I should say sine inverse of x over a is equal to, and this is the one that's 1 over the square root of a squared minus x squared. Okay? So that's what you've got to know right there, is that the derivative of sine inverse of x over a is 1 over the square root of a squared minus x squared. Okay? You just got to be familiar is what it comes down to. And the ones you were told to memorize were what? Sine and tangent, if I recall.
Yes.
So. Oh my gosh, what is?
You would say something we didn't have to memorize this week, or if there's something else that we should memorize.
Right, and that's why I was just double checking to make sure my statement still stands.
As far as I know, it's sine and tangent are the ones that we
It's sine and tangent are the
But it's
two
not
that.
on the product.
Huh?
It's not on the
Without
product.
cosine, come on. I will throw it.
Give the cosecant.
Okay, hold on here a second. I have way too many graded
You guys remember when she didn't have the smartboard? She was doing like the.
That's another person.
You know what was weird the other day? I thought about how in like kindergarten, or at least kindergarten's traction class, we still used one of our, now she's Mrs. Graves, we used one of the like projector cards.
Oh, yeah.
And for some reason I thought about, I'm like, hey, so like a lot of the teachers up here would have like had projector cards. And like imagine learning calculus on like a dimly lit wall with a projector.
Hey, I used to always teach everything on the overhead. Like writing on the overhead screens. That's what I used to always do. Okay, so I will stand by my statement of sine inverse and tangent inverse are the two to know.
You guys, I think it's gonna be tangent inverse in the test since this is sine inverse.
Well, on number
But there's-
8, it's tangent.
Yeah, so we still have to know both.
Okay, well, never mind
Those would be opposite.
I honestly, I haven't looked at that.
Okay, so anyways, back to number 5. First of all, one thing that might help you is realizing there's a random 3 in there. That random 3 is the numerator. That 3 can be pulled out front as a constant. And so another way to view this is 3, oops, I changed color, times the integral 0 to 1/2, and then it's 1 over the square root of 1 minus x squared. Now, does that kind of match up better? Okay. So you have to watch out. You know, constant on top can be factored out. It doesn't have to be left there. So the 3 out front stays. So what is the integral of 1 over the square root of 1 minus x squared? And that's going to be, you have to recognize this part right here as sine inverse x. Now, I guess officially, should I say sine inverse of x over 1? Because what is our a value? Right here, remember this represents a squared. But that's just 1 squared. So nothing fancy, just recognizing that a is 1. If this was, say, 4 minus x squared, then we'd have to have like x over 2 here. We'd have to get fancier. So this is 3 sine inverse of x evaluated from 0 to 1/2. Okay. The 3 I can keep out front. And I'm doing sine inverse. What am I writing here? Yikes. Sine inverse of 1/2 minus sine inverse of 0. You guys remember how your sine inverses work?
You have to find whatever angle equals that.
Yeah. At what sine inverse of 1/2 says sine of what angle equals 1/2. But this is also where the half circles fall into play. So for sine, it has to be something on the right half, right? Has to go from negative pi over 2 to positive pi over 2. Well, according to your chart, sine of what angle is 1/2? Pi over 6, 30 degrees, right? So this is going to be pi over 6 minus, when is sine 0? In other words,
0.
yeah, sine of what angle is equal to 0? Well, remember, ordered pair, right? 1, 0. And so y value is sine. So 0 degrees is 0. So you really end up with 3 times pi over 6. So 3 pi over 6, which reduces to pi over 2.
There's a force problem.
Okay, so as you guys talked about, and we can go there too if we need to, but you know, 5 referred to sine inverse, 8 refers to arctan, so tan inverse. So those are the two to know that you need memorized. So the idea that the derivative of tan inverse of x over a, tangent is the one that does not involve the square root, right? Is this the one? I'm trying to remember how they write it here. A over a squared plus x squared. Okay. So that's the other good one to know. Okay, where would you guys like to go next?
At some point, number 11 looks a little fishy.
Looks fishy?
Just because it's got words, though.
Sorry, I'm laughing because so during homeroom this morning, so I asked a couple of my Algebra 2 kids how'd the homework go. And they said okay, and it was except for the word problems, and and I said, you guys, so my joke was, you guys need to not let those word problems intimidate you. Don't let them bully you. And that was,
I can read and do math at the same time.
yeah, and then someone said, I'm not going to stand up to him. And I'm like, no, you have to stand up to him. Okay.
I think I get the general direction it's going. I just don't see how to finish it.
Okay, well, let's see what the issue is. Number 11. Let R be the region in the first quadrant bounded by the graphs of y equals 3 over x and the x-axis over the interval from 1 to a, where a is greater than 1. Sketch the area of R. Notice it says sketch. So what's one of my points going to be for?
We have to draw it.
If it says sketch, you need to have a sketch, right? That is sometimes one of my points as I kind of assign points, what I give you points for. If it says sketch, rest assured, there will be a point, at least one point devoted to the sketch. Okay,
What if we just drew you like a tiger?
well, I'm not sure. Usually that point is devoted to a correct sketch.
What if you get the right answer from that tiger?
The tiger's like.
The tiger says.
Again, if your work doesn't match up, I don't necessarily always give full credit depending on the situation.
Depending on the situation.
So if it's a tiger problem.
Okay, so y equals 3 over x. And it says, bounded by the graphs of y equals 3 over x, the x-axis, and it did say the first quadrant. Forget 3 over x. What's 1 over x? Technically it's the first quadrant and third quadrant hyperbolas, right? What Abby's testing on right now. But she's doing when we learned them on the x and y axis. This is our reciprocal function, right? There's technically one down here, but it specifically said the first quadrant. 3 over x just means it's not quite as close to the origin. That's all the 3 over x means. Again, you could have graphed it on your calculator if you needed to, right? Over the interval from 1, so there's my arbitrary point of 1, to a. And what's the restriction it gives on a? A is greater than 1. So that just says that a is to the right of 1. That's why they put that restriction on there. When you just say 1 to a, we need that definition. Find the, let's see. So R is the region. So if we're talking about R being that region under the graph, right? Between 1 and A. So right there is your region of R. Yes? Because R is the region in the first quadrant bounded by the graphs of y equals 3 over x, x-axis, interval 1 to a. Find the value of a such the area of R is equal to 27. So my area is equal to 27. What does your calc brain have to tell you about area? Area is integral. Didn't they just set us up for area here? Or an integral? So we're going to do the integral from 1 to a of what was my function? 3 over x dx. Carter must have forgotten. Did you forget?
You're correct. I went to lunch, and by the time that I got to my Mr. Stanley's, I was sitting there, and I'm like, there was something I was supposed to pre-calculus test. So hopefully we are here tomorrow and lunch tomorrow. Next day that we are here in school, I plan on lunch. That'll be good.
Okay, that'll be good. Okay. The idea here is the integral from 1 to a of 3 over x dx is going to equal 27. Right? That's the idea, is that whatever we get here, that equals 27. That's how we're going to find a. Now, similar to the last problem I did, that 3 up top, is that throwing you off? realize that 3 can do what? Did I do that on the answer key?
Just throw
I didn't really. You can take that 3 out front, and it's 3 times the integral from 1 to a of 1 over x dx.
we kick them.
Oh, now that's a lot more doable, or at least
It should be more recognizable. What is the integral of 1 over x? Natural log of x. So this is 3 times the integral of natural log of x evaluated from 1 to a. So, you guys okay if I put the 3 out front and then I say natural log of a minus natural log of 1? And technically, I'm going to throw it back in right now. What does that equal? That statement, that expression, equals 27.
Oh my goodness.
What should you know about the natural log of 1? It is 0. So then I have 3 times the natural log of a equals 27.
Left, right, middle. Wait, so we need to do the
Divide by
whole
the 3
thing.
first.
Do something with the 3. I would prefer, life will be easier if you divide by the 3. So if we divide by the 3, now I have natural log of a is equal to 9. And then I would go left, right, middle, because e to the 9th is equal to a. Or in other words, a is e to the 9th. Okay? So it's not a's and b's, it's an a. Not the a's and b's that Maddie was scared of here, but
Yeah.
still.
It's good. This
It's-
one's pretty low.
Okay.
Number 2 looks slightly intimidating.
Number 2 looks
I thought
like
it was. I had a whole bunch of work on the back,
Oh,
and then
so
I looked
did
at
I.
this answer key because I got stuck, and it's like,
Yeah.
oh no, just put in your calculator.
Yeah, I would really.
This-
that was really hard.
See,
Look how much I wrote out. Oh, it's just-
And then for number 5, I was like, just plug in the calculator. So I just kind of switched them. But
Yeah, well, that work.
so 2 is just plug it in.
number 5.
well,
I would not take just plugged into the calculator because you'd give me a decimal answer.
yeah. Well, I
So.
realize that now. Well, once I looked at the study, I was like, oh, this is
Yeah.
awkward.
Number 2, there's a lot to it, and it gets really ugly, which is why I have it as a practice your, in deriv
Done.
using the calculator.
So
What?
We've done.
On a
We've done
test.
indirect before. I seriously don't remember it.
No,
Yeah.
but it's number 8 on here. Oh, well,
9.
On El Testo, will you accept just the calculator from that, or do we have to do it log messy?
On something like a number 2, I would accept calculator.
Okay, sweet.
Now, however, in practice for AP, you don't just put an answer though.
Yeah. But
I mean, you're basically writing down the problem that you would type into the calculator. Okay? So, don't just give, that would be my comment there, but
I don't know, I feel like number 2 on the test is gonna be a multiple choice. Just get that vibe from it.
I'm not sure because I was just trying to remember which one that correlates to, and I don't know off the top of my head, so.
Oh, it's not even on the test.
Just boost it.
it's
It's
just
usually
here
on
for
the
fun.
test, so. Okay. So number 2, if I tell you plug that into the calculator. Now, do we know how to plug cosecant into the calculator?
Isn't it
You
just sine?
Sine, but you don't do sine inverse. You have to do like sine of x to the negative first, right?
Yes. So cosecant is the reciprocal of sine. And so when you put that in on the calculator, you do sine to the negative 1 power, which is not second function sine on your calculator. You have to do sine to the negative 1 power. Okay? So yeah, I would practice, make sure you can use the calculator there,
So
Oh, I take that back. Inderiv is number 8. I was thinking integral, so.
you said that
Oh, yeah.
Oh,
cosecant is sine of x to the negative.
should be the new math teacher.
Yes.
Oh, please.
Cosecant would be sine to negative first.
Sine of x.
Yeah, sine of, yeah, sorry. You have to put a variable in there.
Miss Sargent, were you good at math next week? So this is.
Although I will say, calculus was a challenge for me.
So Mr. Stanley said that teachers. So we were talking about teachers yesterday, and he was like, I feel like people who like teach their subject and are really good at, are people that struggled with like their area because they're good at teaching it because like their teachers weren't as good as teaching it, so they like feel the need to teach better for their students.
No, I felt like I was good at math, although calculus was a struggle for me.
I don't know. That's just what he said. But then I feel like I don't ever foresee Miss Minnick being bad at English.
I can't imagine Miss Minnick as a.
See, like, I wasn't necessarily bad at English, but I just didn't enjoy it as much.
I switched.
So-
I used to love English, but I don't really more than that.
See,
I like.
I used to like
I like
English.
English.
I used to like English back when it wasn't like
Grammar.
read this book and then you have to find all the symbolism and crap.
Now see, that's what I like about it though.
See,
I
I
think
just
I
like to
prefer
read.
science and math because
I
it's like
can't
one answer.
stand.
I used to really
symbolism
prefer
anymore.
math just because I was like better at it, but I like diving into this.
See, math, I think that now I like better because it's just like stable. Like there's not like you don't have to like find deeper meaning.
No, but
Like, all these
English,
different
English though, if you
interpretations.
just make a good enough argument, you can make any answer the right answer.
I guess that's. I think it depends on the teacher though, because I don't think I could ever argue with Minnick about what I think the symbol's different.
Good. I bet if you like, actually, I think it's like this, and you gave me a reason, she'd be like, that's your point.
You're good at that. I just I'm like, yeah, you're right.
So if you're done teaching, you just want to give us all this, alrighty.
Good for you. Girl power.
You were talking about the awakening, and you just said the theme is women. She'd probably be like,
You're like,
see that?
I vibe with that. I vibe with it.
Oh my gosh.
No.
No, I.
Are you at degrees?
Oh my goodness.
You know why I'm in degrees?
I saw you looking at that problem for such a long time. You were just like staring at the calculator. I was like,
She's like, I've been teaching math for all these years.
No, I just. I
she did all of
couldn't-
her life. She went through the 5 days of grief just sitting there.
I was. Okay, I just realized we're recording this whole thing.
Yes.
Okay.
Um,
Oh my god.
No, I was trying to show how to plug it in on the calculator, and I got the wrong answer. Now, keep in mind, in pre-cal right now, I just yesterday frustrated with them with the, is your answer the same as mine? It's not.
Oh,
And
aren't they doing the
Degrees to radians.
degrees, minutes, second, that thing?
Oh, that was last week.
Okay.
But yeah,
'Cause, yeah,
yesterday was the day when, okay, how do you find sine of 15 degrees on your calculator? I punched in sine of 15, and of course I made sure I was in degree mode, and I got it right. And a bunch of them got it wrong. And, you know,
we've all been.
yeah.
that
And I
was-
purposely don't really point out the direction that says, make sure you change your mode.
Have they done the? What was,
Okay, is there anything else we're gonna do? Or we like,
We had to prove
We still
things.
got
I remember there was like a
So-
big thing last year because everyone, when the proving.
Or,
yeah, they're not there yet.
I
So,
was good.
okay,
I
anything else? Let's see.
I think we got
If anything, number 1 looks a little sketchy because it's
I-
just formatted differently than what I think.
I did it, but I got positive 32. But I don't know what I did.
For that one, don't you just switch the?
Yeah, you'd have to flip the second integral and make it -3,
Yeah.
and it would be the integral from like 6 to 4. But then that gets a little wonky for me at least because it says then find the integral from 4 to 2. So you're doing it like backwards, aren't you?
Well, I flipped the first one, and then I got -7.
No,
so that's
it
why
would
my
just be
4 was
7
negative.
minus
When I
3
squared it, it got positive. So I was like, I don't know.
Yeah, and then you're supposed to add them when they're like.
Okay, I didn't flip either of those right there.
Oh.
Okay, they're wanting me to find from 4 to 2. I'm like, I didn't flip either of those. And maybe that's why it's wonky for you guys.
I was just testing.
Okay. What I did is when I start to work this one, this is where I kind of flipped it, I think. So, okay. I guess what I looked at is we need to know 2 to 4 essentially, right? So I looked at the idea that the integral from 2 to 4 plus the integral from 4 to 6 has to equal the integral from 2 to 6. Is that kind of what's going through your brains? That as we look at these integrals, maybe?
I don't know. Keep going.
Okay.
Because
But,
that's one of the
I mean, okay, so this is the connection you guys are all seeing as you see the 2, the 4, and the 6. Because you guys are talking about flipping one of them, right?
Yes.
Something has to flip. But we have to keep it so that it ends with the integral being from 2 to 6. So my brain knows, okay, the integral from 2 to 4 plus the integral from 4 to 6 has to equal the integral from 2 to 6. Now, what are we provided? The integral from 2 to 6 is 7. The integral from 4 to 6 is 3. And so I kind of did like first grade type math there of what plus 3 is 7. And that is 4. So what I know right here is the integral from 2 to 4. You see what I'm kind of trying to make the point of here? Is equal to 4. Now, our integral isn't 2 to 4 though. Our integral is 4 to 2. And so I guess I have it written out in fancier notation there. But I don't know an integral from 2 to 4, do I?
No, you know the integral from.
I know the integral, or I'm saying that backwards, but I don't know this integral from 4 to 2. I know the integral from 2 to 4. So what I did here is I did the negative, and I flipped right there and say, okay, it's going to be the negative of whatever we end up with. And so it's a negative of 2 times this f of x quantity squared dx. Now, do we know the integral from 2 to 4 of f of x?
Yes, it's 4.
And that's equal to 4. That's what we had right there. And so what I looked at is, so it's the negative out front. We have this 2 here, and you know what I probably should have done is pulled that 2 out front. But then that's going to be equal to 4, and so then 4 squared. I feel like I didn't do a very good job of writing that out. I guess the other option is if I put the negative out front, put the 2 out front, then it's the integral from 2 to 4 of f of x squared. And the idea right here is this integral from 2 to 4 is of f of x dx. So this integral from 2 to 4 of f of x dx is equal to 4. So that's where I can say negative 2 times 4 squared. So the negative does come from the flip-flop. I hope I saved myself there at the end. I don't feel like my explanation was wholly on par, but
I get it.
okay. Okay. Number 12, a random thing I want to point out. It says sketch a graph of f and label all max min values. Make the effort to say max min and write that next to it, because that will cost you a point otherwise. Okay? I have it underlined on the answer key, but label when there's a max or a min. It doesn't say label inflection point, but I did. Remember, first derivative is increasing, decreasing. Second derivative is
Okay.
concave up, concave down. A first derivative 0 could mean min, max, or inflection point. By the time you get to second derivative though, I guess it depends again, but you're thinking more inflection point. I don't know, I feel like there's some others I want to cover now as I start to look at them more. 3 could be good, 4 could be good.
If I have any other questions, is it still okay to come in during homeroom?
Always.
Perfect.
If we have a home.
Oh. Now, not gonna lie, I would not mind not going to school tomorrow, but
I wouldn't mind taking a test tomorrow. I just don't want to go and present in the next class.
I don't.
Okay.
Especially for an entire class. I'm gonna